Hello guys, you're watching Learn C from Scratch and welcome back to my channel. Today I'll be talking about constant. So what is constant actually? Well, constant refers to the fixed value that doesn't change during an execution of the program. And it is of two types, numeric constant, character constant. And numeric constant is further divided into two types, integer constant and real constant. Similarly, character constant is of two types, string constant and single character constant. So let's move to integer constant. What is integer constant? Well, integer constant refers to a digit or a sequence of digits, and it is of three types, namely decimal integer, octal integer, hexadecimal integer. Decimal integer refers to any combination of digits from 0 to 9 and preceded by an optional positive or negative sign. So 3, -5, plus 54 are examples for decimal integer. Similarly, octal integer refers to any combination of digits from 0 to 7 and with leading 0. So here leading 0 marks that this is an octal integer. This is also an octal integer. Similarly, any combination of digit which is preceded by 0x are considered as hexadecimal integer. So here 0x 5ac, 0x to 3de are examples for hexadecimal integer, and it consists of digits from 0 to 9 and letters from A to F, which can be either capital or small. Now let's talk about real constant. Look, integer constant cannot be used to represent the magnitude which is continuously varying. For example, distance, temperature, prices, etc. So the concept of real constant was brought in. Actually, real constant refers to a numeric constant which consists of both integral value and fractional part. So, and there are two ways of representing real constant, which are decimal point notation and exponential notation. Exponential notation is also called scientific notation. So in decimal point notation, an integral value is followed by decimal point and fractional part. So here 5.67 is an example for real constant. Similarly, minus 4.58 is an example for real constant. Here minus sign represents that this is a signed real constant and it refers to negative value. Similarly, plus 988.7635 is an example for positive real constant. 0.12 is also an example for real constant. And here in scientific notation, 0.567E1 is an scientific notation for 5.67. Actually here E represents 10 and 1 represents exponent. So when you multiply this 0.567 by 10 to the power 1, it becomes 5.67. Similarly, when you multiply this minus 0.458 by 10 to the power 1, it represents minus 4.58. Similarly, when you multiply this plus 9.887635 by 10 to the power 2, it becomes 988.7635. And similarly, when you multiply this 12 by 10 to the power minus 2, it becomes 0.12. So this particular example here tells that scientific notation supports both positive or negative unary sign. Now let's talk about character constant. So character constant is of two types, single character constant and string constant. Single character constant refers to a character enclosed within a pair of single quotes mark. So here character can be either a letter or a number or any special character. So here M enclosed within a pair of single quote mark, and this 5 enclosed within a pair of single quote marks, and the capital A enclosed within a pair of single quote marks are examples for single character constant. And each of these single character constant has ASCII value associated with it. Now you must be wondering what ASCII value is. Well, ASCII stands for American Standard Code for Information Interchange, and this is generally an integral value. So yum has an integral value associated with it. Similarly here, this single character constant 5 doesn't represent integral value 5. It has different integral value associated with it. And at the end of this video, I will show you guys how to display an ASCII value associated with single character constant and how to perform arithmetic operation on them. Now let's talk about string constant. So string constant refers to a character or a sequence of character which is enclosed within a pair of double quote marks. So here m enclosed within a pair of double quote mark is an example for a string constant. Similarly here this is a single character string constant because only one character is enclosed within a pair of double quote marks. Similarly here is a sequence of characters enclosed within a pair of double quote marks, so it is also an example for string constant. Similarly ABC 3H F5 are also an example for string constant. And here this single character string constant doesn't have any ASCII value associated with it because it is different from single character constant. Look, this is single character string constant and this is single character constant. So string constant doesn't have any ASCII value associated with it, so we cannot perform any arithmetic operation on them. Since you have studied numeric constant, let's see if you are able to figure out a valid numeric constant or not. Here I have mentioned some of the constant and you have to tell me if these are valid numeric constant or not. So the first one, plus 5.0E3, is it a valid numeric constant? Yes, it is a valid numeric constant. And this is an scientific notation for real constant. And what about this one, 25,000? Is it a valid constant? No, this is not a valid constant because comma is not allowed. And what about this one, 7.1E4? Is it a valid numeric constant? No, this is not a valid numeric constant because space is not allowed. And what about this one, minus 4.5E minus 2? Is it a valid numeric constant? Yes, it is a valid numeric constant. And this is a scientific notation for real constant. And what about this one, $255? Is it a valid numeric constant? No, this is not a valid numeric constant because special characters are not allowed. So this is dollars here is a special character, so it makes it invalid. And what about this one, 1.5 capital E plus 2.5? Is it a valid numeric constant? Yes, it is a valid numeric constant. Here look, it doesn't matter whether this E is capital or small. It is still an scientific notation for real constant. And what about this one, 0x7b? Is it a valid numeric constant? Yes, this is a valid numeric constant and it is a hexadecimal integer. Now let's move to displaying an ASCII value associated with single character constant using C language. So let's include a standard input output header file. Now let's move to an inclusion of main function section. So this is the basic template for main function section. Now the syntax for a statement which is required to display an ASCII value associated with a single character constant to the standard output stream is So this is a syntax to display an ASCII value associated with character. Since I don't want this to be displayed on the standard output screen, I'm gonna comment it. Look, it is grayed out. It means that it is commented. Now it will not be displayed on the output screen. Now let's follow this syntax and try to display an ASCII value associated with single character constant m. Now you must be wondering what is this %d is. Well, in the upcoming videos I will talk about this format specifier %d in detail, but for now what you need to keep in mind is, since ASCII value is an integral value, %d format specifier is used. So we have successfully followed this syntax, and look here, the ASCII value for m will replace this %d and it will be displayed on the output screen. So let's save it. Let's go back to our terminal. Let's compile it. Let's run it. Look, it's displaying ASCII value of m is 109. Now I want to add an ASCII value of 5 with an ASCII value of m. So let's go back to our source code, and here we'll make some changes. First we'll print the ASCII value associated with 5. So we are going to follow the same syntax. And here instead of m it is going to be 5, since we are going to display an ASCII value associated with 5. Here also we are going to insert 5. So an ASCII value for 5 will replace this %d. And since we want to add an ASCII value of m with an ASCII value of 5, let's again write the same statement. Here it will be ASCII value of, here it will be sum of ASCII value of m and 5 is %d plus m. So look, this single character constant 5 will be replaced by its ASCII value, and this single character constant m is also going to be replaced by its ASCII value, and both of them will be added and it will be displayed over here instead of %d. So let's save it. Let's go back to our terminal. Let's compile it. Look, it is successfully compiled, and let's display it. Look, it's displaying ASCII value of m is 109 and ASCII value of 5 is 53, and sum of ASCII value of m and 5 is 162. But all of these statements are displayed in the same line. So in order to make it look good and appear in the next line, let's go back to our source code, and what we will do is we'll insert a backslash character followed by n. Here also we'll insert a backslash character followed by n. So this is a backslash character and it refers to new line. So let's save it. Let's go back to our source code. Let's compile it. Let's display it. Look, displaying ASCII value of m is 109, ASCII value of 5 is 53. Now sum of ASCII value of m and 5 is 162. Look, if we add this to number, it will be 162. Now what if we want to display single character constant provided that we are given ASCII value? Now in order to display a single character constant for which an ASCII value is 106, I'm going to replace this m by 106, and this %d with %c, and here character for ASCII value 106 is %c. Now let's save it. Let's go back to our code. Let's clear it. Let's compile it. Now let's run it. Look, it's displaying character for ASCII value 106 is Z, and here it's a small z. And ASCII value of 5 is 53, and sum of the ASCII value of human 5 is 163. Now let's go back to our editor. So guys, this was all about constant. So if you like this video, keep your thumb up, subscribe to my channel, share it as much as possible, and yeah, don't forget to hit the bell icon to stay updated. Thank you for watching. See you in the next video.